So Raymond, can you show us the flowchart?
Yeah, so we started brainstorming and we came up with the water pump for agricultural areas. So at first, I had a lot of failing pages and parts didn't fit sometimes. So we had to go back and modify everything, and then we started printing and finalizing our notebook, and then we made modifications. Now we're putting the video together, and next step is to finalize everything and submit it.
Right on.
And let's get to the CAD software. All right, James, what are you doing?
So right now, I am drawing the axle to fit into the gear. Because we need a way to connect all of this through the plate of like a cover to the gearbox. So the crank needs to go through a hole and into the gear, and we need to draw a circle that is 10 millimeters in diameter and extrude it down until it can touch the crank. So that's about 17 millimeters. Now we're going to select new body because we don't want it to merge with the crank yet, but we do want it to merge with the handle, so we're going to press combine. We're going to combine these two bodies together. Now it's looking a little rough, so we need to add fillets to make everything look nice and neat and clean. Fillet here. And another fillet here. And we're going to extrude those out 18 millimeters. Now our handle's looking really nice. So we turn off the opacity on the gear and make sure everything's connected and looks right. And that's how we make our crank.
All right, Chime, what do you got to do now?
So now we have to 3D print and slice our design. So we go to File, 3D Print, click on what you need to 3D print, set your refinement to high, and make sure that the output, you do not have this selected, okay? Now you save it as whatever you would like. So I'm gonna save this as modify handle.stl. And then you go into Cura, where everything is prepared already. Open up your design, and you need to rotate it to the best position. So you have to look at what position would use the least amount of support material. And what I found is that if you rotate it 90 degrees and then you align the bottoms at 9 degrees, use the least amount of support material possible. So you want to set your quality to standard, always 20% infill, supports on because we have blank area that needs to be supported, and you press slice. Okay, now Raymond, can you please pass the phone to me and preheat the printer? Yep.
Alright, let's go.
Okay, now, can I have the SD card, please? Thank you. Now we plug the SD card into the computer, and we select, we go to preview, make sure everything is going to print well. Okay, we select save to removable drive, eject, and it's saved as CE3 modified handle now. Now we need to wait for it to preheat, and once it's done preheating, we will print out our design.
Cool.
Now that our printer is preheated, we scrape the plate of any residue that may have built up. Then we put our SD card in. Now Raymond, if you would please select print, select our handle, and let the printer work. Right now we're going to talk about what we designed, why we designed it, and the materials we used and why we used them. So we designed a 3D printed water pump that uses a 2-to-1 gear ratio and a hand crank to spin it half as fast as a motor, but only using human power. We made this part because it solves the problem of agriculture and irrigation in rural areas in third world countries where they might not have electricity. And we chose the material to be PLA plus because it's a very strong and lightweight material that is also water resistant to an extent. But it's also really easy to print, and there's not much aftercare you have to do with it, like sanding and all that. But overall, the put together and the print was really easy and simple. And here are some pictures of the final product disassembled. Me and Raymond both really enjoyed working on this project, and we hope to work together again at the state level maybe. Thank you so much for your time.